Hello, my name is Larry, and this is the latest installment of the Old Gazer channel, which is all about amateur astronomy, and specifically it's a channel where we try to give a little advice, some practical suggestions, and maybe a little encouragement to those who are beginning amateur astronomers or inexperienced amateur astronomers as you work your way through the learning curve to become an amateur astronomer. So that's what we're all about, and welcome. If this is your first video, welcome. If you've seen some of my others, welcome back. And with that, let's just get started. If you've been with me sometime, if you've seen some of my other videos, you will probably know that the last few videos have been about telescopes and eyepieces. And then in the last video, we talked about deep sky objects, what they are, how to find them in the sky, and so forth. And so in this, I want to take things a step further with this video and talk about something known as true field of view. Now, what is true field of view and why is it important? Well, true field of view has to do with what you're going to be able to see when you put your eye up to the eyepiece of your telescope and look at whatever object you're viewing. How big is the field of view going to be? And that's important to know because, as it turns out, there are some objects in the night sky that are actually very large and require a large field of view to observe. The moon has an angular size, if you will, of about 1/2 a degree. Which, you know, is you normally think of the moon as being the largest object in the sky, but it's not. There are other objects in the night sky that are actually much larger than the moon in terms of their angular distance or their angular size in the sky. And we just don't know that because they're very dim and we can't see enough of them to realize their true size. All we can see is probably the brightest parts of the cores or whatever of these objects. So we just don't realize how big they are and what it takes to get them all in the field of view of a telescope. Now, what do we mean when we talk about an object being X number of degrees big, if you will, in the night sky? Well, of course, you know that you may know, probably know, that there is something called the celestial sphere, which is an imaginary sphere surrounding the Earth, and on the surface of which we project or describe all of the objects that appear to be in the night sky and that move across the night sky. It's a sphere that has an axis that is coincident with the axis of rotation of the Earth, and it has a total circumference of 360 degrees. And within each of those degrees, there are further breakdowns into something called arc minutes and then arc seconds and so forth. And that's how we can describe the coordinates or the position of an object in the night sky, but it's also how we can give an indication or a measure of the size of objects in the night sky. If for example, you know, we say that the moon has an angular size of 1/2 a degree, that means that the full moon takes up 1/2 of one of all of the 360 degrees that make up the celestial sphere. So that's what we mean by that. How much space the object takes up in the night sky, usually measured in degrees or arc minutes or arc seconds. Now, the moon, as we've said, has an angular size of about 1/2 degree. I think it averages out to about 31 arc minutes, which is about 1/2 a degree. So if you wanted to view the moon, the full moon, and you wanted to get the entire lunar disk within the field of view that you're looking at, then you would need to be able to see at a field of view of at least 1/2 a degree and probably a little bit more, just to ensure that you're going to get that whole lunar disk in the field of view. Now, there are some objects in the sky that are much larger than the moon. We just don't know it because they're so dim. We can only see a tiny part of them, if that. But the Andromeda Galaxy, of course, is the classic example of a large object in the night sky. It has an angular size of, roughly 3 degrees, more or less, which means that it's about 6 times larger than the full moon. And you're going to need a lot of field of view in order to take all that in if you want to see the entire galaxy in the field of view of your telescope. Okay, so let's talk about true field of view. That's the measure that we're going to be looking at to make sure that we've got enough field of view to take in the Andromeda Galaxy. In the video that we did on eyepieces, we talked about the field of view, the apparent field of view that was one of the specifications of that eyepiece. All eyepieces have a field of view associated with them, and usually that ranges from roughly 40 degrees up to over 100 degrees, and everything in between. And so you might think, well, if I've got an eyepiece with a field of view of 60 degrees, let's say, and I want to look at an object that's takes up an angular space in the sky of 3 degrees, I'm all set. That's way more than enough field of view to take that object in, or any other object in the sky that I might want to look at. Well, of course it doesn't work like that, as I'm sure you probably might realize. When we say that an eyepiece has a certain apparent field of view, let's say 50 degrees, that means that when we look through that eyepiece, without it being inserted in a telescope, we're going to see a field of view of 50 degrees. If we just hold the eyepiece up to our eye and look, that is going to give us a field of view of 50 degrees. Now, when you insert that eyepiece into a telescope, things become altogether different, and the field of view suddenly becomes many times less than the stated apparent field of view of the eyepiece alone. Okay? And what you see when you look through an eyepiece looking through a telescope is called true field of view, and it gives you a true indication of the angular span of the sky that you're going to be able to see when you look through a particular given configuration of telescope and eyepiece. Now, you won't be surprised to know that there is a formula to calculate true field of view. It probably seems like there's been a lot of formulas in these videos, and I guess there have been, but at least they've all been very simple formulas, very easy to calculate. You don't have to have an understanding of advanced calculus to calculate these things. So this is just one more little simple calculation to add to the list here. Here is the way you calculate true field of view. True field of view is equal to the apparent field of view of whatever eyepiece you're using divided by the magnification of the object you're looking at. Okay? Now, there's two things you can infer from that equation immediately, and that is for an eyepiece with a given field of view, the less magnification, the greater the true field of view is going to be. And you can also infer from that for a given magnification, you're going to get more true field of view with an eyepiece that has a wider apparent field of view. Okay? I hope I'm getting across here without, being confusing, but I think the best thing to do is to just go through a couple of examples here. I'm going to use in these calculations my 8-inch Schmidt-Cassegrainian telescope as my telescope of choice. And we're going to look at a couple of different eyepieces to use with that telescope, and we're going to calculate what the true field of view is going to be. For example, that telescope has a focal length of 2,032 millimeters. Let's just round it off to 2,000 for simplicity and ease of calculation. A focal length of 2,000 millimeters. Let's say that I'm going to use this 25 millimeter eyepiece in that telescope. You may remember from past videos, I think we've covered this in a couple of videos, magnification is equal to the focal length of the telescope divided by the focal length of the eyepiece. So in the example we're looking at here, we've got the telescope has a focal length of 2000, the eyepiece has a focal length of 25, so we're going to have a magnification of 80 when we use this eyepiece in that Schmidt-Cassegrainian 8-inch telescope, a magnification of 80. Now, this eyepiece happens to have an apparent field of view of 55 degrees. So, if we use the formula for calculating true field of view, which is the apparent field of view of the eyepiece divided by magnification, we will have 55 divided by 80, or somewhere around 6/10 of a degree. Okay? That's what the true field of view is going to be, just a little more than 1/2 of a degree. Now, if we wanted to view the moon, that would work, because the moon has an angular size of about 1/2 a degree, and we should be able to get the full lunar disk within the field of view using this eyepiece in that Schmidt-Cassegrainian telescope. So that would work. If, however, we wanted to view the Andromeda Galaxy, which has an angular size of about 3 degrees, more or less, then using this eyepiece in that telescope is not going to work, because we need 3 degrees to get it all in there, and we've only got a little more than 1/2 a degree true field of view with this telescope eyepiece combination. Using eyepieces with a longer focal length and a wider field of view is really not going to help us a whole lot in this instance. Let's consider, for example, this eyepiece, which has it's a 24 millimeter eyepiece with a 68 degree field of view. It's very similar to this one, except it has a considerably wider field of view. If we go through all the calculations with that, we will find out that now we have a true field of view of somewhere around 0.7 or 0.8 degrees, something like that. Still not nearly enough to get the Andromeda Galaxy within the field of view. So I think what's apparent from this is that big Schmidt-Cassegrainian telescope with its long focal length is not a good choice for trying to view large objects such as the Andromeda Galaxy in the night sky. You're going to probably want to use a telescope with a much shorter focal length, a wider field of view to do that. Now, for example, let's consider, suppose I wanted to look at the Andromeda Galaxy with my small refracting telescope here, which has a focal length of 350 millimeters and an aperture of 70 millimeters. If I put this 25 millimeter eyepiece in that telescope, the magnification is going to be about 14x. 350 divided by 25 is about 14x. And the field of view of this eyepiece, as we've stated, is 55 degrees. So if you take 55 divided by 14, all of a sudden you've got a number that's greater than 3. And so using this eyepiece and this telescope is going to give us a true field of view that should be big enough to show us the entire view of the Andromeda Galaxy, including the full extent of the spiral arms, those faint spiral arms. So that shows you, hopefully, why true field of view is important and why you need to take that into consideration before you just go out and try to view some object in the night sky. The best way to use this information, in my judgment, in my opinion, if you want my advice, is to include true field of view in your planning for observation. If you know you're going out to look at the Andromeda Galaxy, and you know which telescope that you would like to use and which eyepiece you would like to use, then determine what true field of view that's going to give you. And if it's less than 3 degrees, you're not going to be able to see the whole Andromeda Galaxy within your field of view, and you probably need to make some changes accordingly. Now, of course, it's possible to take several different pictures if you're into imaging or photography, of the Andromeda Galaxy and then, you know, kind of stitch those together into a composite panoramic view. And a lot of people are into that and really do that. I know absolutely nothing about how to do that and really don't care to know anything about how to do that. But you know, I'm mainly concerned about just getting the object within the field of view of my telescope. So that's how you can do that. You know, try to plan accordingly so that you've got the right combination of telescope and eyepiece that will give you the true field of view that you need to get the object within the field of view of your telescope so that you can see the whole object. Okay? Now, where do you find the size of objects to use in these calculations? I would suggest using one of the resources that I recommended in the last video, which is an internet site that gives you a lot of very good information about all of the objects in the Messier catalog. One of the bits of information that it gives you for each object at that website is the size of the object in arc minutes. Now, arc minutes, there's 60 arc minutes in a degree, so you can easily make the transformation from arc minutes to degrees there. So that's a good place to find out what the angular size of what you want to look at is, that you can then use in the calculations. And in case you didn't see that past video, I will include the link to that website in the description part of the video so that you can have that if you want to go and take a look. So that's what true field of view is, and that's why it's important, and that's why it has to be taken into account, especially before you go out and try to view some of these larger objects in the night sky. Okay? Hope that made sense. Now, you don't have to calculate true field of view and every time you need that calculation. There are some resources out there on the internet, or perhaps available as smartphone apps, that will do all of that for you, and in a very interesting and visual way. I'm going to show you two of these resources, if you will, and I will include links to them once again in the description of the video. One of these is an online internet resource called astronomy.tools, a wonderful resource that's good for not only determining true field of view like we've been talking about here, but it does a number of other good things for an astronomer as well. You just Google astronomy.tools. There's no .com, there's no .org involved. It's just astronomy.tools, and you know, you can access it on the internet. The other one that I'm going to review briefly with you is something called Stellarium, which has a free download version for your laptop or your computer, and it's excellent, by the way, which I think you'll see. And you can also get this as a smartphone app. I think there's a free version and a paid version, which will, of course, have more features. But I'm not sure that the smartphone app, the Stellarium smartphone app, is as functional, has as many functions as the computer download. Not sure about that. You can investigate that and check that out. But let's look at astronomy.tools and Stellarium and see how they can help us in this matter of trying to make sure that we've got enough true field of view to view the object that we're trying to observe. So let me pull these up on the computer. We'll take a look at them, and then when that's finished, we'll come back and we'll wrap this video up. Okay. This is a resource, an internet resource known as you can see, Astronomy Tools. Very easy to get to. You just Google astronomy.tools, or put that as the URL, and it'll take you right to this. There's no .com, no .org, anything like that. Just astronomy.tools, an extremely useful resource. This includes a field of view calculator, which is what we're going to be interested in for this video. So let's go to that. And this will let you put in any object in the night sky. It will let you specify any telescope and any eyepiece, and whether or not you're going to be using a Barlow lens or perhaps some kind of focal reducer or whatever. And it will show you what the object that you've selected is going to look like. given the combination of telescope and eyepiece that you have indicated. So let's go up here and say we want to look at M31, the Andromeda Galaxy. Okay, let's say that I'm going to be using my Celestron NexStar 8 SE, and it'll automatically fill in the focal length and the aperture for you over here. Let's say that I want to use my favorite eyepiece, which is my Baader Hyperion 24 millimeter eyepiece, and it will fill in the focal length and the field of view over here. And now you have told it you want to look at the Andromeda Galaxy using this telescope and this eyepiece. You click Add to View, and it'll show you what you're going to see. You can see the area contained within the red line there is what you're going to see when you look through your telescope with that combination of eyepiece and telescope. So you can see that about all you're going to be able to see here is going to be the bright core of the Andromeda Galaxy. So that's not going to work if you want to get the entire galaxy within the field of view. Let's go back up here and say change eyepieces. Let's say that we're going to use a wider angle eyepiece and a lower powered eyepiece. Let's use this 36 millimeter eyepiece right here. Now, we've changed eyepieces. Now we have a focal length of 36 and a field of view of 72. Let's see what that looks like. And there you can see in the area enclosed by the yellow line, we have greatly increased the amount of the galaxy that we're going to be able to see. Still quite a bit of the galaxy there that you can't see with this telescope. You'd have to go to yet a wider field of view, shorter, even a longer focal length eyepiece with a bigger field of view. Or in this case, this telescope allows me to use a 6.3 focal reducer, which increases the field of view and decreases focal length and that kind of thing of the telescope. So if I were to put my 6.3 focal reducer on here, now I can pretty much see within the blue line there the entire galaxy, just with a little bit perhaps of the spiral arms, the faintest part of them out there on the ends. So this just gives you an indication of what you can see given with a given combination of telescope and eyepiece. So that's how this works. Very, very useful. Let's just do one more thing with this. Let's say that I want to change to my telescope that's not on here. You can, if your telescope is not on the list, you simply pick Custom Telescope and manually put in the focal length, which is 350 for the one that I'm going to use, and put in the aperture, which is going to be 70 millimeters for the one that I'm about to use here. This is my little telescope. Of course, there's not going to be any reducer involved here, but if I use my Baader, my old favorite Baader 24 millimeter eyepiece with this small refracting telescope, here's what I'm going to get. And as you can see now, I can see a very wide angle of the sky and easily get the entire Andromeda Galaxy within that field of view. So that's how this tool works, and that's how you can use it to see what it's going to look like with any given combination of telescope and eyepiece. Now you can also, if you wanted to take a picture of the Andromeda Galaxy, you can change this to imaging mode, and you could pick a camera. Let's just pick a Canon 60 here, and it'll fill in the resolution and the pixel size and so forth. You can do add to view, and in that rectangular area now it will show you what the photograph is going to look like, what's going to be included within the field of the camera. And there you can see that would make a nice view where you get Andromeda completely within the photograph with a good bit of star field around it. So that's how that works. Now, let's go to another app that does something very similar. This one is called Stellarium. Stellarium. And it's a free download, which you can get on your computer. They also have an app, a free version and also a paid version, which of course would have a lot more features associated with it. Another very good app. Now, you can tell here when I brought Stellarium up here that it's got the current time where I live, and it's, you know, early morning here, getting up towards mid-morning actually. So that's kind of what you see here. Let's change the time. Let's move ahead in time a little bit. And now the sun has set, and it's, let's see, now I'm up to about 9:30 p.m. local time. Let's go search for M31, the Andromeda Galaxy, okay? Now, that now has the Andromeda Galaxy centered in the screen, and you can, you know, move in, zoom in, and there it is. That's about what it looks like right there. With the unaided eye, you can barely make it out. Now, suppose I wanted to look at the Andromeda Galaxy with my customary Beta eyepiece in there, and with my small refracting telescope with an objective of 70 millimeters and a focal length of 350 millimeters. That's what I would expect to see. That's Stellarium's version of what I would expect to see. And so there you can see, very nice view that has the entire object in it. Let's say that I want to change my telescope. That's what I would see using my 8-inch Schmidt-Cassegrainian telescope with that Beta eyepiece in there. And as you can see, once again, you cannot see a good portion of the object. If I put my focal reducer on there, then that would give me a much more decent view of the galaxy. Still would not be able to see it all, so I would need to go to an eyepiece with a lower magnification, a greater focal length, and probably a wider field of view, and then I could probably see it all. This one has the same option. I'm going to go back to my other telescope. Now I'm back to my a little Meade telescope, 70 millimeter focal length, 70 millimeter objective refracting telescope, and that's the view that you would get. This also shows you what it's going to look like if you wanted to take a picture. In this case, I've got this set up to reflect my Nikon D3100 DLSR, and there's what the picture would look like if I wanted to image the Andromeda Galaxy. That's framed very well. You can see the entire galaxy and a good bit of star field around it. Of course, you'd have to take multiple time exposures, or if you have a very nice tracking scope, a few very long time exposures to gather the signal you would need to make it look like that. But at any rate, that's what it would look like if you were to take a photograph using that Nikon D3100. Just wanted to give you an idea of some tools that are available so that you don't have to calculate that true field of view every time for a given eyepiece telescope combination, but you can get a visual picture of what it would look like using apps like Astronomy.tools or Stellarium. I hope that was as clear as mud. I don't think I did a particularly good job with that, but maybe you got the gist of it. At least you now know where to go to find these tools, and you can play around with them and use them until you get familiar with them. I always use one of these tools before I go out for a night's viewing, pardon me, so that I will know in advance what things should look like when I finally get them in the field of view of my telescope and can observe them. And that way I can avoid the disappointment of finding something that won't fit in the field of view, or which might be so tiny in the field of view that it's, barely noticeable. These are just excellent planning tools to help you know in advance sort of what you can expect to see when you get out there and experience the joy and the excitement of seeing the real thing through the eyepiece of your telescope. So, that's about all I've got to say about true field of view. If you want to know more about it, you can research it to your heart's content by Googling it and getting it on the internet and looking at other videos and that kind of thing. But that's what it is, and that's why it's important, and that's why it needs to be taken into account when you're preparing to view certain objects, particularly the larger objects in the night sky. Thank you very much for stopping in. And let's conclude this one, as I always do, by sincerely wishing all of you clear skies and good viewing.